So, who am I and why you maybe should listen to me? And also, thank you for coming to this and not the other thing, which is probably more interesting. So who am I? Why should you listen to me? If you enjoyed either of these books, I worked on those. I hope you enjoyed them. I've been a site reliability engineer at Google for a bit now. I started in indexing, then went into storage for a while, and now I work in cloud. I am the SRE presence in Chicago since 2012, working remote. That could be a whole other talk, but it won't be this one. And because a lot of us have imposter syndrome, I've been a college graduate since last year, so that's kind of cool. So don't let titles freak people out, because there's lots of us who don't have them. And then, I don't know, occasionally I'm on Twitter, so find my rants there. So people always talk about SREs, like, let's automate ourselves out of a job, let's automate everything. But frequently, like, what if we have absolutely no idea what we're doing, and we're asked to automate something impossible that we don't have the first idea about? So that's kind of what this talk's going to be about. So this is going to be having a case story kind of interwoven through it. So what I do at Google is I am the TL for cloud expansion. If you work on GCP or AWS, you probably have names that represent locations that look like these. A couple of years ago, these were the original four. These are the original 4 Google regions. And management decided that in order to grow the business, we need to have a lot more of them. Certainly at least 5, maybe 6, maybe more than that. And the problem was, these weren't really designed. They kind of grew into existence through evolution as people figured out like what services we might want to build, how we might want to build them. So there wasn't really a unified design doc for how these things existed. So when we needed to build more of them, we had absolutely no idea what we were doing. So this is what we did. It was fantastic, and this is the end of my talk. So just follow this procedure, write some bash, I guess, and we'll go open up for questions. So no, we had 2 real challenges. First of all, figure out what is the overall process to build a cloud location, and then for every single participant in that cloud location, say like if you're providing VMs or blob storage or things like that, you probably need to figure out what you're doing as well. So figure that out, and then build that back into one. So general problem with automation is we get problem statements like that, and then we think of pictures like this, hopefully, which is, you know, because I have to cite all my images, gives the joke away. A lot of automation projects are secretly waterfall software development in terms of you need absolute perfect knowledge of what you're doing before you start, and you have no ability to deliver any kind of incremental result. It's either completely done or you have nothing. And people will ask you, how long will it take to deliver that automated process for giving us, you know, brand new regions? And I have no idea. So everything that we've learned about software development, you know, and built into various different processes like Scrum and Agile, we throw out the window when we think about automation. So that's not great. The other failure mode that we see very often is we love to talk about automation, we love to write automation, but maybe we shouldn't do any of it, because, you know, doing something like a data center build is probably going to be astronomically expensive in terms of time effort to write it. But how often are you going to need to run that automation? You know, if a classic example that comes up, you know, where I work is that for load balancing configuration, it's tremendously difficult given how it was written and the configurations used to write good, reliable automation. But a human expert can generally do anything required in about a minute. So you kind of weigh off, you know, is it really worth writing a program to do this, or is it acceptable for a person to do it? So if you think about something, if you have like a huge, you know, huge automation effort and you're only going to use it once a quarter, it's probably not worth automating. But it might be, depending on if you need to verify certain qualities about the output. Like if it actually needs to be perfect, it absolutely needs to be right, then it's worth maybe automating. But otherwise, you know, that's a bad trade-off of your engineering time. So thinking about the cost of defects. So, again, all my jokes ruined by citations. Any double E's? Anyone? Oh yeah. So this is how I like to think about automation. This is the you know, the schematic symbol for operational amplifier. So instead of thinking about automation as a way to replace people, I like to think of it as a way of like, how can we write programs to amplify people? Because human judgment has value. It's not something you should look to eliminate. You should look to figure out how to get more use out of it and more impact out of it. So Because we work in the software industry, we like to believe that every idea we come up with, no one has ever thought of before, and it never could have happened before. So it turns out a lot of the really cool ideas about automation actually were developed decades ago by people at Toyota. This is a book that I'm going to plug. I think it's pretty cool. It's called the Toyota Production System. And they have a lot of thoughts about automation, and if you can look past the fact that they're building cars and think about how it relates to what you're doing, there's a lot of valuable insight there. Like the people at Toyota really felt strongly that automation needs to respect the role of people in the process and not dehumanize them. I think that's pretty cool. They felt very strongly that human judgment's valuable, that there is a value in expertise as opposed to something you should look to eliminate. And they had a very, very strong opinion about standardizing work as opposed to having free-form everything, and that relates a lot to programming. So read this book. Other big takeaway is automation is not actually a goal. Like, no one cares about writing automation. Well, you care about what the automation does. Like, if you're given a project, is your job to build an assembly line or is your job to build cars? So your stakeholders don't care if you built the greatest assembly line ever. They care about your cars and if they have all the right number of doors and if they're coming out on time. Automation itself is not something you should be looking to fill the time of the day with writing. So when you do it right, you get back human time in terms of how you spend your day and what you can focus on. So again, this is not a very software-y talk. The simplest automation possible that I think is the best way to start projects like these is to write bytecode for the human interpreter and write yourself a checklist. And if you can't explain how a person might do it, you have no chance of explaining to a computer how it should do it. So that's where we start. So in addition to that, you really want to think about interfaces because taking a step back and remembering that you have a software project of sorts that you need to develop, these things called like collaboration and coupling end up being things you care a lot about, especially if you're working across teams. Because if you can't neatly and concisely explain what you're asking someone to do, you're probably not going to like what they do for you. So you're starting with we need a checklist, we need a process, we need an interface, because if we don't have that, we can't do collaboration. And this is really important for the case study I was talking about, because you needed to get teams across the company working together towards a common output, and frequently they would need to interact with each other. And if you didn't think about things like this, no forward progress actually was possible. So getting back to this, like I was saying, our goal wasn't to write automation. Our goal was really to provide an SLO for the business on if they asked us to build a location. In this case, this was one we did in India. If I say that it's going to take us 8 weeks, and that's our SLO, just as a number thrown out there, can we actually do it? And when we come out of the tunnel at the end of that long process for configuring and building things and racking up machines, are the products that we want to be there going to be there in the state we want with the right capacity? So thinking about interface, inputs and outputs, thinking about SLOs, about how long it's going to take. The goal, no one cares if I write this in Python or Go or how I accomplish it. They care about the output. So next time you play Pictionary, this is the top image result in Google for ambiguity. That's a good one. So a big challenge in automation, again, is for problems that tend to be more interesting, it's very difficult to know every possible detail and explore something in complete depth, because there's always more to know and there's always someone else you need to talk to about something else. So we took a step back and realized that we would actually never completely comprehend what we were asked to do, and that was going to be okay. We looked at our inputs and outputs. They're asking us to build a new cloud location. Our outputs, configured as requested, and that was the only thing we didn't know how to do. And then we worked backwards by trying to get people to self-organize by looking at different products, say like Google App Engine or Google Cloud Storage, and saying, well, what are your inputs and outputs? What do you need? Who are your stakeholders? Who are your collaborators? So the plan was to get to the left side of the screen from the right by having them self-organize. So rather than me figuring out how all these things are wired together, and also if anyone can identify what's in these hexagons, you win a prize. I can't. So that's what we started to do. So instead of writing one gigantic checklist to rule them all, we came up with self-organizing checklists. So instead of having one doc that's going to describe in detail, sequentially execute this from top to bottom, and you'll end up with a new cloud location, If we can figure out the structure from the previous slides of how these products interrelate with each other, we can basically build a graph of checklists for human interpreters, making sure, and also some discoveries we made along the way, cycles are really bad to have in this because you're not going to be able to ever complete. So figuring out where your cycles exist and figuring out how to break them. And at least at this point, even though you haven't written any code, you can actually do something. And that's a big step forward. So when we built, secret here, when we built the Tokyo region, which was, I want to say, region number 6, this is what we had. And it worked. So we want to make incremental steps. We've gone from having a bunch of checklists and maybe getting a bunch of people in a war room every day to talk over GVC about who's blocked on who and working through to figuring out how can we start turning this into code. So again, apologies for all the bad Python analogies here, but I was hoping to make that more clear. So we've got a bunch of checklists. We have no code. We can start to think about interfaces, and we have kind of a graph of how all our services connect to each other, but we're still implementing English. So we need to get past that. And in a traditional software project, like I was talking about before, we would now block maybe for like 1 or 2 years until we figured out how to do this, and then only when it was completely done would we get anywhere. So we came up with the novel idea of human remote procedure calls as a way to advance our human bytecode through this very new novel technology called issue tracker. Maybe Jira, maybe something else like that. But there's a lot of really cool things about abusing this technology in ways that maybe it wasn't anticipated for. If you use the default template in most issue trackers, you can spell out what your interface looks like pretty well in terms of, fill in, these are all the fields, the things I require, these are the resources I need, this is, my dependencies. Also dependencies, most bug trackers have a dependency management system. So, if this bug depends on that bug, you obviously can't make progress. That's a great way, if you have maybe a bunch of program managers, project managers, they can very quickly assess what's going on because all of the things they would need to know are already built in this representation. Other cool thing is tracking state. It's either open or closed. So if someone asks if something's done or not, you can find out. So we started with that. That was the next step. We have our checklists. We can file issues to people and ask them to do the checklists, and we can figure out where in the graph we are from if bugs are open or closed. We can have maybe things in like a hot list or a bug list to figure out overall process. We're incrementally moving forward. So we looked at more ways we could maybe creatively reuse things that already existed for different purposes. In this case, we did not want every team to go out and redevelop their own data center automation system or figure out where we're going to start, how we're going to start doing this. So what other thing that already exists can we abuse in a new way? In this case, it was the release engineering tool Sisyphus, I think we mentioned in our first book, which was originally designed for people to be able to push out web search in a more automated fashion. But one of the things that was cool about it is it's basically a toolkit in Python for letting you do arbitrary things in production. So we have lots of arbitrary things in production, so maybe we can use this tool to do it. So we'll come back to that in a minute. So we had asked a lot of teams to go out and come up with these checklists, and the next thing we need to do is make sure our checklists are machine readable. And this is from a code lab I wrote for a hypothetical cloud service that has some parameters and things like that. So you would have to have instructions for someone to read. It can't be written on a napkin, can't be in an email, that someone, hopefully the most junior person on your team who just started, can follow this thing and get predictable results. So it's all in here. Read the thing top to bottom, do the stuff, get the output. And then our interesting idea was, what if we abused markdown and put annotations inside it in the form of HTML comments that we could have a computer program read to basically figure out from this human readable document, how can we extract things that are discrete pieces of work in an overall process? So I know it's hard to read in here, but this is the raw source for the page I was just showing. And there's these little sections in there that say doc task and then the name of something. And in some cases, it'll say doc task, the name of something, and then depends on the name of something else. And this is the way that we were able to encode structure in our playbooks of do this, then that, and not until the other thing. So what we ended up doing is, using that tool I mentioned from a minute ago, we wrote some code to basically extract that into scaffolding for our tool that was designed for release automation to turn into computer code. So I think this is actually, not that it's particularly interesting, the first screenshot ever in a public space of Sisyphus. But they approved it. It's not particularly interesting. It's a form. We have some inputs that we defined. We need an interface. What region are we building? What environment are we using? Maybe like if you're a distributed computing type of thing, what cluster are we going to put it in? And then from that, we get this, which is the text that we had in our runbooks a minute ago with super lazy markdown formatting, because I'm not particularly good at CSS or JavaScript, but the content's there. And the really novel thing to look at is that there's a button right there that says task has been completed by a human. And why this sounds not very interesting, we now have basically a web server that's running our checklist, and it's stateful. So if it gets rescheduled, it'll come back up in the state. If I'm working on something and I go home and go to sleep, instead of the checklist being written on my desk or maybe being like scribbled in notes in an issue somewhere, the person who comes on shift on the other side of the world picks up the checklist exactly where I left off, and has the exact instructions that they can start working through. So now we have a checklist that can work across shift boundaries, that's stateful. It has a lot of neat qualities to it without being particularly technically interesting. So what will end up happening here is as you start working through this and you click that, because we've encoded the dependencies into that scaffolding document that we have, if this completely fails, we still have a checklist that can work. The checklist is the source for this. As that changes, this will change. And the dependencies that are spelled out, if then that, will basically figure out where's the next place that checkbox that says task has been completed by a human shows up. And as these come through, you can't really see it, but there'll be little green blobs that pop up to say that it's done. So now what we've done is we have kind of a pseudo program for doing things. So the other thing I should have mentioned, actually, we'll go back one, is the other thing that made this novel and why we chose to do this is because we have this Python toolkit for doing stuff and arbitrary things, we can, as we figure out how to automate things, we can replace the instructions for humans for a specific task with an actual piece of programming. So in some of these that are trivially simple to automate, like run this command, dropping in a little bit of Python to run that command, we can, instead of having it say task can be done by a human, the system will automatically do it when it gets to that step. And why this is interesting, as opposed to, yeah, great, you made some incremental progress, is that we have incremental progress. Instead of waiting for the entire thing to be done, we now have a system that allows us to do selectively. Some of this is done by a person, some of this is done by a computer. And every time we make any kind of code contribution to this project, we're improving the overall state and we're not waiting for a perfect outcome. If we're able to get 50% of these tasks automated, we've reduced the total toil for doing this by 50%, as opposed to being like, yeah, check back next quarter, we didn't get it done. And that ends up being really powerful, because if you look at that oversimplified checklist as like one component of maybe like 50 or 100, instead of waiting for this overall super process to be 100% automated, we can move and make progress at the pace of every single team that's collaborating to it. And to our overall system, especially because at the top level, my team started out with just one of these that would ask different teams to start theirs. It's a black box via the interface. I don't know, and I probably shouldn't care, how much automation they've actually done, as long as they're providing something to an SLO. I ask a team, how long will it take you to turn around, getting service X up and running? And they say, I don't know, 4 days. I care about the SLO, I care about the interface, but how they choose to implement that, I could care less. And in some cases, some teams decided, we can do this very quickly. You only ask us to do this maybe once every couple of months. Our automation is going to be issue tracker. And that's fine, as long as they produce the right output. Teams that are more complex, that have more nuance to what they're doing, make the decision that they're going to invest in more automation. And each team is basically allowed to figure out where that balance is for them. As long as they're meeting their SLOs, and as SREs, we deeply care about SLOs, we don't care. So it turns out that's a pretty effective way to do things, in my opinion. We started out knowing nothing. We had 4 regions, and despite that, several years later, we built all of these. And in the process, I think, stay tuned in the next month for that white one over there in Osaka. This scaled. We got the results we wanted. And as more products were invented, because the shape of the cloud when we started in Tokyo was not the shape of cloud we did when we just, what did we just do? Zurich a couple weeks ago. There's maybe like 5x the number of products, the complexity changes, the internal representation changes, and our system has managed to keep producing results despite this, by just being very simple and thinking about process and SLO instead of implementation details. So If you've completely fallen asleep and you didn't listen to any of that, this is really the 4 bullet points I take away with. Never think about automation, think about impact. Remember that you do software. Don't do waterfall, unless maybe you're in an industry that you have to. But think about how can I pick away at this a little bit every day so that every day I have something that's a little bit better than I had yesterday and always be shipping. And then think about, especially if you work across teams, please think about interfaces and think about how you can make the interfaces look the same for common teams. Like when we started out, we had every team basically, because I didn't know anything, say I have no idea what you might want. You tell me. And everyone got to define their own interface. But maybe about 3 or 4 regions in, we realized that maybe 90% of teams had given me the exact same thing. So now we have a common interface. So think about that. Think about checklists and think about SLOs. And again, you have a lot of smart people working for you. Think about how to get the best out of them. Don't look to replace them. And I think we're a little early, but I'll take questions. You got them.
All right, so for questions, either you can come up to this microphone here or you can raise your hand really high so I can actually see you.
How do you think about testing things that happen infrequently but have production impact?
I'm sorry, I heard testing.
Yeah, so when you're working on something like this, it's something that happens infrequently. You can't actually run the code that often because you only have so many data centers to spin up. How do you think actually testing it in a way that isn't going to break stuff, isn't going to cause lots of
That's
whiplash?
A fantastic question. So making sure I understood reparsing it. Now, how do you think about testing large-scale automation and just automation in general? Because if you only use it once a quarter, you frequently are finding breakage while you use it. I think there are some things you can do that give you some protection in terms of standard software development stuff, like you should write unit tests for your stuff and things like that. But actually testing against production tends to be really hard. Some people try and test against staging environments, run your automation to build a new staging environment. But that can be problematic in that a staging environment usually has deficiencies that make it slightly different from production, and you end up building something different that is similar but still different. You get some assurance from that, but maybe not as much as you'd like. The other problem with things like this is these are construction processes. If I have my assembly line picture, we don't have the analogy to that, which would be like the scrapyard of after you build something, how do you get rid of it safely, especially if you have configuration that isn't completely hermetic. It turns out that doing a turn down is the opposite of a turn up can be dangerous, because if you have an off by one error, whoops, you just blew up production. You're building kind of like automation of mass destruction. So it ends up being really hard. You try and do the best you can. Being able to respond quickly to defects as you find them, because a lot of times not just are there bugs, the shape of production might have changed out from under your automation. It's probably a whole other second talk there, but I think that testing large-scale automation is still kind of one of the big unsolved problems in production management. And I think the best answer I have to that in general is to try and figure out when you're duplicating business logic about how your system operates outside of it in a separate program, these things are eventually going to get out of skew. And you can think maybe that, as like a bad analogy, the overall maturity of the software you're trying to automate is inversely proportional to the amount of automation you wrote. So if you have simple interfaces that are part of the system itself, and you maybe have your automation is like a single terminal screen height of script that says, all right, system, go do these things, and that logic's part of the system, and that's tested as part of your release engineering, I think that's the best you can do now, but I'm sure other people will come up with clever ideas that we didn't think of. But if you have them, I'd love to hear them. Anyone else? All right. Find me in the hallway if you didn't want to talk on the microphone.